Hi, my name is Bob Greenyer and I'm a volunteer with the Martin Fleischmann Memorial Project. So thank you for joining me on this Saturday, the 16th of March. I'm here, as you can see, in Alan Goldwater's Magic Sound Lab. You can see the lovely von Neumann microphone over there and the speakers. Can people hear me? Because this is a totally different setup, so I have no idea whether this is going to work. Please, if you're in the chat, let me know if you can hear me. Excellent. So we have Artifact in the house. We have Misunderstood in the house. And I think there is, because it's very unusual for me to share anything on a Saturday. But this day, I think it needs to be shared, what I'm about to share. And that is new data. We were expecting this week to come in, and we have got some data. So what am I talking about? Well, if you recall, I did a video where I scratched off from 5 2-inch by 2-inch samples of the inside of the outside of the Thunderstorm Generator that was running in Melbourne for about 8 years, about 500 hours of testing. And I got together about, I think it was 6 milligrams of material, and I sent that off to a specialist beamline that does a method not radiocarbon dating by looking at the counts from the decays of the carbon containing material and looking at that particular photon that comes out, but it is a way where they're using a beamline and they're doing some sort of mass analysis by using time of flight, something like that. Don't specifically know, but apparently this is a much better technique, more accurate and so forth. So I wanted this to be the best it possibly could be, and given the fact we had only 6 milligrams, a very little amount, then this was more likely to yield a more certain result, because of course if you have a large lump of coal or charcoal or whatever it is, organic material, then you have more carbon in there to actually analyze. Well, we couldn't actually get much material in this case, 6 milligrams from essentially, what is that? That's 4 times 5, that's 20 inches squared of material. But anyway, sent it off, and what we were intending to look for was obviously the priority was the 14C over 12C. And why do I say that? Well, because fossil fuels should have no carbon-14 in them, because carbon-14 has a half-life of 5,730 years, plus or minus 30 years, and it then decays to nitrogen-14. And so if you had organic material as the source of your fossil fuel, so forth, let's say, then it would take basically, it would, over the millions of years that it's supposedly being a fossil and, you know, it's forming, there should be no carbon-14 in there. It would have all decayed. The other theory is that it is abiogenic and it's synthesized in the ground. But one can also say that if it was synthesized in the ground, you can imagine this is an extremely slow process and that it seeps up into the reservoirs. And again, you would not expect to have any 14 carbon in that material. So the other thing we were going to look for is 13 carbon over 12 carbon, and also 15 nitrogen over 14 nitrogen. And the reason for this is it's the theory that you've got stepwise neutron addition. So there are a number of theories in the Lena field that suggest there is stepwise neutron addition to nuclei, and these basically say that if you keep synthesizing a neutron somehow, so the Widom-Larsen theory is you've got a piece of metal and you've got a surface plasmons, you've got loads of electrons on the surface, and they create so-called heavy electron, and that creates a situation where you can get electron capture, and a proton becomes a neutron, and then that goes into, let's say, another proton, because it doesn't have a charge in that case, and that makes a deuteron, and then that would then make a triton, and then it would make and this is also a theory, but coming from a different angle, of the Brillouin group, where they use these intense electrical pulses, and they state it goes 2 protons joined together making a deuteron, then another proton forms a triton, that's tritium to you and me when it's a full atom, and then quadronium is made, which then decays to 4 helium. So there's 2 examples where there are a stepwise progression through the periodic table, and as you go up, actually when you go past calcium 40, you need to add more neutrons so they don't decay back. But if you keep adding a neutron to a nuclei, it's at some point becomes unstable and will then decay back to a element of the next proton on, the next element on. So you can imagine that is how you would go through the periodic table. So what we're looking for in those 15 nitrogen to 14 over 14 nitrogen is an abundance of 15 nitrogen over and above what you would normally expect in the natural material, and again with the 13 carbon over 12 carbon, and to a certain extent the 14 carbon over 12 carbon, if that's more abundant than it should be, then you can argue that possibly there's some of this process of neutron synthesis going on and adding to nuclei. Now, my understanding is that basically material becomes coherent and gets forced into a very, very small box. And this is the phase singularity in the magnetohydrodynamic fractal torus structures. And there it gets stopped, and it kind of has to produce heavier and heavier nuclei to pack the material into denser and denser, higher binding energy elements, with the last of those elements typically being iron, and specifically iron 56, and that would then come out and it ends up forming this shell around the overall magnetohydrodynamic structure. So stuff goes in, it gets pressured effectively, electromagnetically pressured in that center, and because it's got a toroidal moment, the relic neutrinos have a toroidal moment, they can also be sucked in, and you have an environment where you can get fusion all the way through and typically end up by producing a lot of iron. So you can imagine more heavier elements were produced, but you would have to go to iron and then have a lot of iron in there and then move on from that. You still gain energy every time you add a neutron or a proton to a nuclei and take it along the table. There's a net gain there. It's just when you get to very heavy elements, you actually sometimes, for instance, if you fission uranium into sort of half mass fractions, something like cesium-137 or whatever, you actually gain, because the 2 nuclei actually occupy less overall space-time than the whole uranium-235 atom. But as you're building up to, say, uranium-235, you still gain a little bit of energy, even though you go by, you have less binding energy per nucleon. Okay, so, or rather you have more binding energy per nucleon. So the most binding energy per nucleon is in the iron 56 and to a certain extent nickel 62 as well. Okay, so that is the framework. So what we are expecting to see is a series of data come back from this beamline. Unfortunately, says the person that took the sample and the group that did the analysis, they said there was not sufficient quantity of material for carbon 14 and delta carbon 13 and delta nitrogen 14. So what they did was they took the whole 6 milligram and used it for a more accurate carbon 14 dating. Okay, so that is the framework. We do not expect to see this material have any carbon 14 in it whatsoever. So it shouldn't really have a date. It's just basically, and it's interesting because when the person who runs the laboratory, or the representative I was engaging with, he says you know, what's the sample from? And because I said I don't have anything on the list that meets the sort of type of sample it is, because typically what they're doing is they've got a pot that they found in some archaeological dig, and there's a piece of material in there, and they scrape that off and they send that off because they're assuming this is food that came from an organic source, and it's the remainder of that food, and they send it off, and they can work out how old this pit in the ground was because of the food crust. And they can do that. For instance, there's a bone of some animal or some person that's died, and they scrape off the bone. So they have these different options that you can use on their drop down. They didn't have one from an internal combustion engine. So I said, you know, what sort of thing should I select? And he says, well, what is it you're trying to get an analysis from? And I said, well, it's from an internal combustion engine. And then there was a pause in the email communication. He wrote back and says, I don't understand why you would want carbon dating from an internal combustion engine. And I thought, yeah, of course you shouldn't see any carbon-14 in there. But I said, look, just it's a special type of internal combustion engine, and that's why we want to do this analysis. So he said, just put down then food crust. Okay, so you know, we've got the data back. How many people we've got here? Hi Lucas, hi RJ, hi Ian Gazda, hi Gordon Doherty. Great to have you with us. Diantai Station. Hi Open Source. Hi Henk, you're in. Hi EBB. Fantastic to have you with us. Right. Here we go. This is the data certificate from the analysis place. And it is analysis that was done in Vilnius Radiocarbon, which is in Vilnius, Lithuania. And it's a Center for Physical Sciences and Technology, and it's Accelerator Mass Spectrometry Laboratory. It's a specialized lab that is highly focused on this very small range of masses. So it's highly, highly accurate. So this is the dating certificate. They did the testing on the 14th of March 2024. I received the results yesterday at end of play on the Friday. And it is for my good self, for the Project Quantum Heat CIC, Community Interest Company. That is the organization that runs the Martin Fleischmann Memorial Project. As you can see, the sample was chosen as food crust. The date of sample they received on the 1st of February 2024. And again, they analyzed it on Thursday this week. So the equipment used for the analysis was single-stage accelerator mass spectrometer, SSAMS and NEC USA, automated graphitization equipment, age 3, this Ion Plus from Zurich. And the method analysis was they take the samples and they pre-treated them with a standard acid-base acid protocol, as listed in these protocols. And this was used as a reference material, this particular National Institutes of Science and Technology reference material. Here are the results. Drum roll. The radiocarbon age of this material is 30,165 years. 30,165 years. Now, think about that for a minute. What does that mean? Well, that means it has got carbon-14 in there. That also means it isn't any biological material like pure biodiesel or some gas from a tip gas, for instance, because that wouldn't even register as being anything other than a few weeks. So as RJ's put this, this is a boom! This is absolutely incredible. But hold your horses. Hold your horses. I'm thinking to myself, wait a minute. If you know that the half-life is 5,730 years, plus or minus 30 years, and as you can see here, the the date it's been given is about 30,165 years. That sounds about a bit like 5 half-lives have occurred. So I'm thinking to myself, could it be that they used biodiesel or a diesel biodiesel mix? Here's me thinking that and I've said it before, that the generator in Australia was using diesel. I've said it on my streams. You can go back to my streams. I was under the impression that that generator was diesel. And so I thought I'd better go and look and see what kinds of biofuels mix they do in Australia. And it turns out, you can go and look at this on Wikipedia, and I'll read specifically from Wikipedia. It says, the names of the diesels in Australia indicate the percentage of biodiesel the fuel contains, with B5 containing 5% biodiesel. Well, that wouldn't fly. Biodiesel blends, most commonly B5 and B20, are becoming increasingly available at service stations in all Australian states. Up to 5% biodiesel can be included in any diesel sold in Australia without additional labelling. So, here's me thinking, if you've got 20% biodiesel in fossil fuel, that would give us a radiocarbon dating of about what we see. So yesterday afternoon, I phoned up Malcolm Bendel, and I asked him, I said, Malcolm, where were you getting your diesel from that you ran in that generator? And he said, we weren't using any diesel at all. What are you talking about? I said, sorry, I thought it was a diesel generator. He says, no, it runs on natural gas. Ah, it runs on natural gas? Really? He said, yes. Why? I said, well, and I hadn't told him the radiocarbon date. I said, it turns out that this has gone through about 5 half-lives. It would occur, you know, it's like it's biological material that's gone through 5 half-lives. So, right. Well, then what we are looking at here in this here is potentially a real thing. Now, here is the actual chart. So you have the OX calibration source up here, atmospheric data from RIMA. It's all calibrated. They've got a probability, 68.3% probability of it being 32,775 years, and it has a 95.4% probability of being 33,166 years. And so they calculate it at the peak of this probability curve of being 30,165 plus or minus 188 years. That is the date of this material. Okay, so this has totally profound implications. It is a stunning finding, and it gives me confidence to go ahead when I do the supernova reactor to see if the thing, if you remember what my plan was with the supernova reactor, is to start with recently made charcoal that I acquired from a German source in barbecue charcoal, and not worry about the other elements that are being made, but see if the quotient of radiocarbon material would have gone down. And we can still do that test. Of course, you know that the person that made the supernova reactor suffered, you know, the ultimate price. And so I wanted to understand strange radiation more properly and how to shield against that before I ran that. So now I've used these guys, and now I understand how to safely or better run experiments with the supernova reactor. I want to do those tests and take some samples, of which we'll have a lot more, and send that off to these labs and try and get some understanding. And in that case, it should be showing, this is the other end of the spectrum, it should be showing that there is nearly no radioactive material in there, or rather it should be, if it's completely clearing up the radioactive carbon, or it should show potentially a reduction, or it should show that it was just a couple of years old, which would fit the actual material that was put in. Okay, now we do know that these technologies take beta active material, of which carbon-14 is, and appear to remediate them. And the technology has always appeared to not produce radioactive material, with one notable exception that was proved by Tom Claytor of LANL, Los Alamos National Laboratory, and I actually stood next to him in, I think, 2016 on June the 5th, on the evening of June the 5th, when he received the Giuliano Preparata Award for synthesizing and proving the synthesis of tritium in the presence of corona discharge of deuterium. So it is proven that, but it's a very small amount, right? But it's proven. Now you can imagine a situation, the idea is that when you have two deuterons fusing, one of the reaction paths produces tritium, okay? And additionally, Teliakin, in his sonofusion experiments published in either Physical Review or one of the other major journals, there was two papers published, I think in 2001, 2002, he used a deuterated fluid. It wasn't water, it was another, I think, an organic fluid. But anyway, he used a deuterated fluid and he saw the production of tritium. So we have one in a plasma system, which is similar to what's going on in Malcolm Bendel's Thunderstorm Generator. And we have another one in a fluid cavitation system. Now, of course, you're saying, well, these are two deuterons coming together, so you can make the argument that it's actually kind of the normal fusion pathway. And in fact, in the case of Teliakin, he claimed to have observed neutron emission, so there's extra support for that. However, Shishkin has recently reported the production of deuterium from light water in his ultrasonic rotation-based cavitator. So this means that you are adding neutrons, and if you can go from protium to deuterium, and in the case of Brillouin and Robert Goddes at Brillouin Energy Technologies, BEC, they are going through this process from protons all the way through to tritons, then quadronium, and then that decays in an extremely small amount of time to helium. So what this implies is that you can have this stepwise neutron addition process, and if that's the case, if it goes from carbon-12 to carbon-13, that's an addition of a neutron. And if it goes from carbon-13 to carbon-14, then actually the nucleus of carbon-14, because it has an even number of baryons, it's kind of bosonic. So it could actually live in these structures, in these magnetohydrodynamic vortex structures in the core. And when it blows up, it spits out a bit. But of course, if it mostly synthesizes carbon from whatever's going in, or it's typically trying to get to heavier nuclei. Well, a heavier nuclei, if you're going from, if you're producing carbon 14, or you're producing oxygen, nitrogen 14, or oxygen, and nitrogen 15, and oxygen 16, 17, and 18, all of these things are stable. Okay, so you can imagine a scenario where a ball lightning, a quantum coherent creation structure, literally a creation structure, is able to take material, stepwise add neutrons to it, and it may be that we are finding here, not only can these structures produce a small amount of tritium, but it can also produce a small amount of carbon-14. Now, what are we talking about? Well, ordinarily, when you have normal or organic matter, like you and me, we will have 1 part per trillion. 1 part per trillion is carbon-14. So if this has got 5 half-lives left, you've got to divide that by 2, by 2, by 2, by 2, by 2. So 2, 4, 6, 8, 10. This is another order of magnitude less than normal organic matter. Okay? But the signal is there. So it might not be, because the traditional theory is that you get this high energy proton that comes from the atmosphere, and it basically interacts with the nitrogen-14 in the air, and it makes carbon-14, and then that carbon-14 decays back. So the idea is that there's a balance in the air. But what also do you have in the environment? Well, you also have lightning. And lightning, as we understand, has ball lightning as its leader that produces the ionization channel, in my view, and in the view of Kenneth Radford Shoulders. And I happen to agree with that view. And so what we're saying is that there could be a completely different method that occurs in any cavitation system, like water crashing on the shore, water coming out of hydrothermal vents, water coming out of aquifers through springs, water flowing down a fast-flowing stream. All of these things where life likes to be associated with, right? And the lightning above are potentially creating carbon-14. Now, I'm not saying that the prevailing theory doesn't also contribute carbon-14 to the environment, and it may even be that that is the predominant source of carbon-14. But if we are to believe what we see from this carbon dating study, then it would imply that, one, these structures are synthesizing heavier nuclei. What we're saying is zero carbon-14 was in the natural gas, the fossil fuel gas. It doesn't matter whether you think it's made abiogenically or it's made from the decay of dead sea creatures or whatever else, right? Crushing vegetable matter, whatever. It's a fossil fuel. It's been there so long that it'll have gone way past the half-lives to make this be only 5 half-lives away, only 30-something thousand years away, 30,165 years. So it would appear that this validates that there is stepwise neutron production in the Thunderstorm Generator. It is potentially a mechanism that underpins the observations of Tom Claytor and underpins the observations of Teliakin and underpins the observations of Shishkin and underpins the observations of Brilliant Energy Technologies and Robert Goddard. And so it kind of really is really interesting data, and we have a method to test the opposite. That these systems, this yin-yang system, likes to balance things, right? So maybe life needs a little bit of excitable carbon in the mix for things to work. Maybe that is the thing that it needs. And so the flower of life, this yin-yang structure, this magnetohydrodynamic structure, is part of the beauty of the design of the universe. And it may be that we can take the 1 or 2 or 3 year old charcoal, process it through the supernova reactor, and if that is not showing that it has basically no half-lives and it's basically new material, and it shows that it is, I don't know, for sake of argument, in the same ballpark as this, we might be finding that nature has a process by which it is both remediating and both exciting matter. So for me, this is a phenomenal potential finding that has immense, almost unimaginable implications for a wide degree of archaeology, paleontology, and so much that has been, you know, we're not going to be the talk of the town in a positive way with this finding. And if it's corroborated by experiments in the supernova reactor with fresh charcoal, there's got to be some serious questions asked about whether, you know, that carbon dating can be relied upon for actually dating things. So then the moving on from this, I've spoken to Malcolm. It's very, very important that we can gather more material from the rest of that 24-inch sphere and look for these 13 to 12 carbon ratios, which will show the intermediary that we're hypothesizing gets us to carbon 14, and also the 15 nitrogen over 14 nitrogen, which will show if nitrogen is in the system, it is synthesizing the heavier isotope through the addition of a neutron. And then the other set of tests that we have an opportunity to do is to look at the ratio of oxygen 18 over oxygen 16. And of course, if you looked at the work of Shishkin, and there's another video that I'm going to finish translating, which is Sergei Godin. He's referring to work that was done at Dubna, the Nuclear Research Center north of Moscow. This is not public work, but they were specifically using specific frequencies to excite water into a, and I will talk about this when I publish that, into a state of matter where it would produce oxygen 18. Then that would be a very interesting finding. And then lastly, the test is that we can do is look for sulfur 34 over the more abundant sulfur 32. Now we know from a Mars gas, which produces a magnetohydrodynamic vortex and is from charge separated and separated water, that actually produces sulfur from oxygen. Now we don't know on that sample, the 10-yen coin, whether those snowballs and cobblestones, as the video is called, whether the sulfur there is actually rich in sulfur 34. The implications of finding an abundance of sulfur 34 is that it supports the observations of Bin-Juen Huang. And that is to say that oxygen 17 is synthesized by the addition of a synthesized neutron, and that those two fuse together to make sulfur 34. And sulfur 34 is the intermediary producing carbon 12 and neon 22. So this is what's happening now is lifting all boats right now. We have a very clear mechanism of magnetohydrodynamics that is leading to the stepwise and bulk transmutation of material. And with that, what I can say is, what is going to happen if I can do the stream tomorrow? You absolutely do not want to miss it. Do not miss the stream tomorrow. Why am I saying that? I'm saying that because the data that I have found on the outside of the inside of Bin-Juen Huang's, DHX2 here, and putting that in combination with the data that I've already been sharing of VCS5RT, this will absolutely nail this to the wall. I think even a 5-year-old could look at the data that I hope to share with you tomorrow, and they will know that this is how it works. And I'm hopefully going to edit what I captured yesterday, on which I'm going to base my talk tomorrow. But it is earth-shatteringly stunning, and it is a real finding, and it makes extremely clear how these magnetohydrodynamic structures are both structured on each stage of formation and what they can do in terms of synthesizing new matter. So with that, I will ask if there's any questions. It'll probably be the same time as today's presentation, 2200 CET, that is 2100 UK time, and here it's 2 o'clock. Okay, so I'm going to see if there's any questions in the chat. But essentially what we are saying today, what I'm told had 0 biofuel in there. There was no tip gas involved with this. This is 100% natural gas, fossil fuel gas, where there should be 0 carbon 14, and hence the incredulous comment that I got from the people, why are you looking at internal combustion engine? What you're seeing on the screen here is paradigm shifting in terms of potentially understanding a major environmental source from this natural process of magnetohydrodynamic ball lightning and cavitation in water-related systems, it changes so much. So there we go. So Craig has said, could you discuss your ideas regarding the similarity of planets to the structures you found and their contents? What I would suggest is that what you've seen that I've already shared from the magnetically separated component of this VCS5RT structure are these iron-rich crenellated spheres, and we noted that one of them was had the same kind of shell thickness, but it was cracked, and inside it would appear that we have established that the inside also has toroidal type structures with a range of elements that appear in our body, the elements for life. But in the core of these toroidal structures, there is higher or an amount of iron in little spherical balls. So it specifically, if you can imagine, we've got our magnetohydrodynamic structure. As we showed in the video from 2017 from Suhas Ralko's lab, when you have a big one here, the disruption or the beam that comes out of that pulls in a little one, and the little one goes in, and it doesn't go out the other side, it goes and joins it. So, and it doesn't seem to change size. So what's happening there is the energy that's in that structure becomes part of the Borg of the bigger structure. And if you could imagine that, it's condensing that energy into those central points, because remember what I said, the bubbles are because of a lower pressurization. It allows the bubbles to appear and the light to bounce off. That means some point in that structure, there's something that keeps pulling stuff into a core, right? And it keeps getting denser and denser and denser. And I think what happens is you have this fractal structure, but in the center of that you have the overall moment, and that synthesizes heavier and heavier elements. And when it gets to iron, probably iron 56, but a range of iron atoms, it's highly magnetic. That accentuates the magnetism, but periodically it gets too much material fed into it, and it spits those bits of synthesized elements out, which are principally iron and oxygen, and then that rolls round and forms a shell, but it still keeps sucking things in until it reaches a kind of stable state. And I can imagine that you have these miniature structures that go into a bigger one, and it keeps building and building, as Solin said in his 1992 patent. You have these toroidal solitons of two magnetic charges that aggregate together in clusters, forming spheres and tubes that in which nuclear reactions occur. And what I shared this week from the material that was given to the project by Bin Juan Huang is exactly what is happening. I don't know how Mikhail Solin knew it, but it seems he was right on the money, which shows that our potential path to direct matter to energy conversion is, you know, based on a good founding, and we have a real shot at doing that. Okay, so any question? Can magneto arrays induce a similar effect? I don't think so, no. The strongest magnet made by man, I think, is the 50 Tesla magnet that was produced at MIT for tokamak fusion purposes. We are talking, according to Lutz Jaitner, of magnetic fields of the order of 50 million Teslas, right? The 5 times the magnetic pressure at the center of our sun, equivalent to the magnetic pressure in a neutron star, okay, a pulsar, a type of neutron star. And so this is incredible magnetic flux, incredible magnetic flux. Now, if you take a capacitor is able to store charge. What is it storing? It's storing electric charge. It's an electrical capacitor. This is able to store magnetic flux. What are we talking about here? Yes, we are talking about Mr. Fusion, flux capacitor. That is exactly what these magnetohydrodynamic fractal structures are. They are magnetic flux capacitors. And they can do fusion. So, oh yes, sorry, boom! Right, Oh, a neutron star almost certainly is this. It's one of these structures. Right. Is there any way we can use this knowledge to create a sort of time compass or device that can find the flow of acceleration and deceleration of the speed of light? I can say that in a certain part of this structure, the place where the Ukonavasara is, this little thing here, right? Not the Tesla logo, or it's a rip-off, but that part there, that is where we get the changing of epsilon zero, the dielectric constant of the vacuum, and in that specific place, you will have possibly even time freezing, and the speed of light will change greatly. But because it removes these relic neutrino clusters, in my view, from a defined boundary around it, if you're inside that boundary of one of these fractal clusters, if the cluster is big enough and you are inside the boundary where it doesn't mash up your nucleons, but it is able to suck these things in, you will have time distortion, in my view. Yeah, Gordon says radiant energy is totally unaffected by the Coulomb barrier. Absolutely. Let's see if there's any other questions here. This is probably what's powering the sun. I don't think the sun has a fusion reaction occurring in its core, and it takes millions of years for that energy to get to the surface. I think it's basically a surface effect by clusters that are very similar to this. I mean, it has depth, it has volume, but it could be that the internals of the sun are just a cold, dead mass. Relatively cold. You know, if you have the entire outside of the sun at 6,000 or so degrees centigrade, then it's likely that all of the matter inside is at least at that temperature, just by the fact that it can't radiate out. But the idea is at millions and millions of degrees in the sun's core, no. I think it's all a waste of time. I think this is done by intense magnetic fields produced by the fractal magnetic structure that leads to it being a fusion device based on being a flux capacitor. So, yeah, I mean, for me, what I have seen yesterday into the morning, well, it was the day before into yesterday morning, I had a long session. I couldn't put it down, and there's a couple of extra things I want to grab, so I left the sample in there. But this is just totally off the charts in terms of, you know, the journey that the MFMP has made. So I have to give a huge thank you to Alan Goldwater for first buying the SEM and then secondly allowing me to use it and in his Magic Sound Lab, which I am currently in, and you can see all the part of this studio here. Yeah, really thank you to Alan Goldwater. It's a seminal piece of effort that he did for the community, and is a great individual to be around. So how does this relate to the core of the Earth remaining hot? Where I heard that in Skyswall, I've wondered how it remained warm. Well, I mean, there's a couple of things going on. If you have, I believe that anywhere you have magnetohydrodynamic structures, which you will have inside the molten mass in the Earth, and we pretty much assume it's molten because you get molten stuff coming out, this will lead to the structures that are able to cohere matter, and that is what I believe the relic neutrino condensate comes down. It is the model of gravity, and because it gets condensed from a very rarefied form of mass into ordinary baryons, the Earth grows and it provides a gravitational well for these things to go through ordinary matter, and for instance our cells, and push us down onto the gravitational well, which is just a thing that's condensing like a steam engine piston is sucked up because the water changes phase from gas to liquid. So that's the kind of analogy that you would need to use. Extremely simple, and it matches very intuitively with the prevailing theory of gravity from the 15th, 16th century all the way through to something that was made in the beginning of the last century. Anyway, so because any magnetohydrodynamic structure will have the toroidal moment can interact and capture this material. And so because it yields energy, and that's what's happening in Binshu Huang's system and other lunar systems, that will keep the Earth's core warm and is probably integral to the way our planet is a habitable place. Gordon, it's not just centripetal force. That is part of the component, but you have a yang and a yin. The yang is able to disassemble matter. It's literally unraveling it. That toroidal moment is able to reach into the nucleus, and in the way that the components in the nucleus are made, it unwinds them into just ordinary vibrational photons, right? And then it passes that matter through to the yin, which is able to assemble it. The beauty is that the yang can be very inefficient because it yields so much more energy than the yin. If you take one proton and you decay that, it's over 900 million electron volts. And if you feed that energy through into the yin then can then use that to drive synthesis of and give birth to new elements and heavier elements. And so when you are fusing two deuterons together per nucleon, that's the most energy you get per nucleon in a fusion process. And it's 25 million electron volts for that whole yield, roughly, but it's only like 6 or whatever it is per individual nucleon. So you have over 900 given by the decay of one proton, and you have only you know, per nucleon it's very, very little to synthesize the heavier elements. So this yin-yang process, this give and take, this great leveler, this black and the white, this is what's doing it. It's both some level of negentropy, but a very low level, and entropy, and together it can make and it is life, in my view. Anywhere there is a magnetohydrodynamic structure, it is life. It has life rules, like Ken Shoulder said. An exotic vacuum object, it has rules. It obeys a set of rules that, you know, it goes around, they interact with each other, they consume matter, they have waste product, and they like to feed, they have a particular food that they like, electrons, but they will consume ordinary matter, and so on. So they're acting like a life form. So it's reasonable to think that they are a type of life, and that we are probably just an extension of this overall driving force in the universe. Do you think that, so Toon Peter says, do you think sonicating a bicarbonate solution could induce a change of isotopic ratios of the carbon? The bicarbonate or carbonates will be charged and interact with, yeah, I'm sure. Yeah, so with this data we've shared today from the Thunderstorm Generator, it indicates that it is possibly producing an amount of carbon-14, and this would be through this stepwise synthesis of neutrons that are go into the nuclei, and this is the balance of what comes out of the system, in the same way that this has been observed for the production of tritium in both plasma and solid state in the case of Brillouin. And so Tom Claytor is plasma in corona discharge with deuterium. Teliarkin was sonnefusion with deuterated fluid production of tritium. Shishkin was production of deuterium in a cavitation system from light water. And Brillouin energy technology, Robert Goddess, is the production of deuterons, tritium and quadronium from light hydrogen. And so, you know, you have everything there as the evidence, I think. And so when we match this potentially with taking normally 1 part per trillion recent carbon-based charcoal, process that in a the supernova reactor, if we end up with something that says it's you know 2 million years old, or let's say it's 30,000 years old, it will be very, very interesting. Okay, so if you've got any questions, I'll ask them. Otherwise, I'm going to go and finish my uneaten lunch. Hi, Jordan. Yeah, this is so. Quest on Channel says this is so exciting. I happen to agree. I think this is either exciting or very dull, but like on balance, it's exciting because it shows that it's not full bio. It cannot possibly have been a biogas source, so it had to have been a mixed gas source at best. And like Malcolm says, no, it was just natural gas. And I've looked into online to see if the natural gas that's available in Australia has biogas mixed into it, and that what they do produce syngas, but it's kind of exploratory and it's not something they really do. And he knows the source where the gas came from, and it is, you know, it's got, it's just natural gas. Okay, so Tammy says, Bob, Mike Mum has a question. Okay, let me see if I can find that. Where was that? Mike Mum. Was it a long way up? I don't know. Can someone ask it again? Copy it from wherever it is? I can't find it immediately. NG says, Bob, off topic, but have you had anyone reach out regarding your new collaboration site that you want to put together? I'll be up for helping out. Okay, not yet, but yes, that would be great, NG. That would be great. So reach out to me from remote view. So Nick Knock, it was you. Can you ask the question again, Nick Knock? Thank you for the offer, NG. I asked about the Thunderstorm Generator lubrication system. Was it run on mineral oil or synthetic oil? Mineral oil has organic compounds. It's a good question to ask. Will it account for 20% of the carbon deposits? Don't know. Maybe. My view on this is that, you know, there are still some open questions. It's almost too shocking to believe. But this is, at the moment, the data is the data, and that's what we know for certain. And, you know, I tried to deal with the obvious potential reasons for this to be what it is. I think the right approach now is to do the tests with the supernova reactor and see if we get, like, this is no years old. You know, we can't determine any age whatsoever on this, or it's quite old, and then that will indicate potentially that and if the same process is going on, you can imagine that if there's an abundance of carbon-14 and that then gets rolled out of the system because it ends up being some heavier element and new carbon-12 comes in, you might end up at roughly this kind of level. I don't know. No, this is not raw data. This is it's got the signature down here of the person. This is absolutely top-notch, based on National Institute of Science and Technology calibration, certified date from this week of the sample that I showed the extraction process on YouTube. You can go and see that. Yeah, I mean, I could do more testing of the carbon-14, but I think really now it's a case of getting more material and looking for the difference in 13/12 ratio, because if the 13 is more abundant than it should be in nature, then this dismisses all of the arguments about it coming from some sort of oils that contaminated the system, or even from the atmosphere, or whatever. You know, because you do get atmospheric carbon dioxide that has this 1 part per trillion, but of course it's 1 part per trillion of 0.004% or 0.04% of the atmosphere is carbon dioxide. So forget that. Like Alan and I were discussing that yesterday, so it's not that. So it's more important to look for the 13C over 12C. If we see a more abundance of 13C, then this is what's going on. Or if we see more abundance of 15N over 14N, then this is what is going on. If we see more abundance of 18 oxygen over 16 oxygen, this is what is going on. Or if we see sulfur 34 in abundance over sulfur 32, then this is what is going on. But like, this is, like I say, there are still things that I can think about that may possibly explain this, but this is the data. This is the data. And so we have other tests we can do. Malcolm's very happy to have me go over and spend a day scraping off even more, some for the sulfur tests and some for the nitrogen 15 and carbon 13 tests. So we'll have a conclusive, in my view, data on this in this half year, I should imagine. I actually have the samples here with me that I looked at before, over here in my bag, and I will probably chuck them on the SEM here and have another look. I also want to get some color macro photography. I need to buy a focus rack for that. I took some very nice ones because the ones in the iron-rich crenellated balls in this sample are 100 microns. They're bigger than the sort of small sort of 10 micron or so structures in the Thunderstorm Generator, but you know, we get we actually can see those with an optical microscope. So I kind of want to get it so that I can use the pixel shifting on the alpha, and then I can quadruple or even times by 16 the pixel resolution. Yeah, so like if you go to the first video I shared on the iron-rich crenellated spheres in the VCS5RT of Binger and Huang, you can see the cover slide there is, and you can see this maybe on Facebook or whatever. That is the quick image that I got using the Sony Alpha and the 5x Laura macro lens. So to summarize, we received a number of 2x2 inch squares, and I suggested that we might look for carbon anomalies, either principally because this is meant to be a fossil fuel, would it have had any carbon 14 in there? If so, this would imply that there is some stepwise transmutation going on in the process that we know from other LENR systems has been proven. And we sent it off to this lab, Vilnius Radiocarbon, probably one of the world's best ways to look for element masses around this carbon 12 through to sulfur 34 range. And they only had enough material, unfortunately, to do the 14C over 12C, but our sample came out to be 30,165 years calibrated result with a high degree of certainty, you can see here, and that means we have a really big question. You know, is this some organic material somehow that gets into the system? I don't know, but I think we can answer that, as I've said, by getting more material and looking for the 13C over 12C, the 15N over 14N, the 18O over the 16O, and the sulfur 34 over the sulfur 32. And combining that with tests in the supernova reactor, we will have very, very conclusive findings about neutron synthesis. And the great thing here is that, like, if you're going from, if you go to carbon 14, having an abundance of carbon 14 means this, that if you have a system that ordinarily causes beta decay to accelerate, then it stands to reason that if you've got an abundance of carbon 14 being synthesized, that can be accelerated to decay to nitrogen 14 in this same system, and that then nitrogen 14 is the ejector that is combining 2 protons, 1 electron, 1 antineutrino and a carbon-12 nuclei to capture carbon-12, capture 2 protons from the H2O that's being fed into the thunderstorm generator, yielding 1 oxygen. And of course, you've taken the 2 hydrogens off the water that came in, so you've got another oxygen. So it's actually synthesizing 2 oxygen atoms, or rather, it's synthesizing 1 oxygen atom from a carbon and 2 protons, and the other oxygen atom is a balance. Sorry, I got that wrong. It's synthesizing 1 nitrogen atom, which you don't detect in the output stream, and 1 oxygen atom. So the oxygen would go up. You wouldn't necessarily notice the nitrogen because we're not looking for it. Now, if it takes the nitrogen and adds another proton and another electron and another proton and an antineutrino, you get going to oxygen 16, okay? And you have another oxygen. So out of this system, if you take 2 carbons going in and 2 water molecules, you could end up with, God, no, I'm going to get this right. 1 carbon going in and 2 water molecules. You would end up with 1 oxygen from the fusion of oxygen, 2 electrons, and 4 protons and 2 antineutrinos. Okay? And you would end up with the oxygen, 2 oxygens left over, so you would end up with 3 oxygens. I think that's right. I can do the equations, but anyway, you end up with a lot of oxygen coming out and not as much carbon dioxide as you're expecting. So JDP says, okay, but does the 30,000 mean something other than just the presence of carbon-14? Actually, that's all it means. It means there's carbon-14 in there, and then we've got to ask, why does that appear in something that's just using fossil fuels? Okay. That shouldn't be there unless there's some form of contamination. And like I say, that is, you know, the only answer left is there's some type of contamination, but the 13C over 12C, the 15N over 14N, the 18O over the 16O, and the sulfur 34 over the sulfur 32 will settle the debate. It'll be done, right? Or I can do the supernova reactor and, you know, I don't have to wait for samples, and that will also support weight to the argument. Yes, Gordon Doherty. I had to choose food crust. That's basically what we agreed we would put it under, because the company does not have internal combustion engine as one of the choices. No. Yes. That's exactly what happened. It isn't food crust. You can see the whole video of me scratching the material off and putting it in the sample container that I sent them. Okay, so I think